Good morning, everyone. What you're looking at right now is a 10-foot by 10-foot Kodiak Canvas Flex-Bow VX tent managing active 40-mile-per-hour gusts on the high-altitude steppe of Wyoming. When most people see wind like this hitting a campsite, their first instinct is survival mode, worrying if the poles will snap or if the canvas will tear. But if you understand the physics of your shelter, high wind becomes a lesson in fluid dynamics. This tent is a tank. But out here, a square footprint means your orientation isn't just about choosing a nice view from your cot, it's an engineering calculation. I pitched this VX model with the aerodynamic profile in mind, but out here on the terrace, the mountains don't always give you a linear wind vector. When the gale shears off the canyon rims, it creates massive invisible forces that standard camping manuals never prepare you for. Segment 2, the core science, the Bernoulli and Venturi breakdown. Let's talk about the science of why tents fail in a blow like this. It's called the Bernoulli Principle. As a fluid, in this case high-velocity mountain air, speeds up, its internal pressure drops. When a 45-mile-per-hour gust hammers the flat back wall of this tent, it creates a high-pressure zone. But as that air is compressed and forced to accelerate up and over the curved, spring steel roof, it speeds up exponentially. That speed spike creates a massive low-pressure vacuum right on top of the roof fabric. The tent isn't just being pushed over from the side, it is literally being lifted upward like the wing of a Boeing 737. On this VX model, that lift is magnified by the Venturi Effect at the side triangle windows. When air rushes past those narrow mesh apex points, it creates a suction nozzle that pulls air out of the cabin, causing the walls to drum and flap violently. If you leave those vents exposed, the wind turns the interior of your shelter into a high-friction acoustic chamber, fatiguing your zippers and your eardrums. Segment 3, the tactical modification, the shade tarp fly. So, how do you defeat a low-pressure vacuum when you can't turn off the wind? You change the aerodynamics. Enter this heavy shade tarp, which I rigged as a custom stormfly. Instead of letting the wind create a clean, high-velocity stream right across the canvas roof, I pulled this tarp taut and pinned it directly to the earth stakes at a steep angle. Mechanically, this acts as a spoiler on a race car. It breaks up the air velocity, destroying the smooth flow and neutralizing the Bernoulli lift. More importantly, it completely blankets the front door tracks and those high vulnerability triangle vents. It creates a dead air zone between the tarp and the interior mesh. The wind can howl at 50 miles per hour on the outside, but behind that shield, the air is stagnant. The zippers are under zero shear load, and the tent floor stays pinned flat to the dirt. Segment 4, the takeaway, the lesson of patience. Setting up a heavy canvas rig in a high wind front is a masterclass in patience. The lesson here is simple. Don't fight the weather with brute force. Neutralize it with physics. Secure your hinge lines first, understand where the lift is generated, and use your auxiliary gear to manipulate the airflow. When you know how to read the air, you don't have to fear the storm. You just adapt the infrastructure, check your tire pressures, and enjoy the ride. Stay grounded out there,